Hello everyone, this is our team presenting our mini project to you guys in this video. Let's begin by understanding the problem statement and the device solution. Individuals with severe motor disabilities often struggle to communicate effectively due to the inability to use traditional verbal or non-verbal methods. This project seeks to develop a thought-to-text system that leverages EEG signals to translate brain activity into readable text, providing a reliable communication channel for these individuals. By addressing the challenges posed by noise and variability in EEG data, the proposed solution aims to enhance the quality of life for users, enabling them to interact more effectively with their environment and others. Now, this is what we presented as a first iteration. We created a Python GUI where creating on the generate data button generated an AI database that you can see. Then we used to click on the button of train dataset, which used to apply a deep model to train the dataset in various epochs. As you can see, the various epochs among 50 comes one by one, and each of them had their own trial loss, validation loss displayed in the main area. Here, graphical image like this is shown, which shows the model loss and the model accuracy. Model loss, as we all know, it represents the amount of information that was lost while training a model, and the model accuracy refers to the accuracy of the model that particular data set. And then we used to use our test dataset button to do the testing. Our first task was to find a good, reliable dataset, which we found from Kara 1, had multiple uh, readings for multiple channels of the brain whenever different types of syllables were said. Now let me show you by opening one of the files. This is a notepad file showing the different coordinates of that were omitted from a brain signal of a person whenever he or she tries to speak a syllable or imagine a syllable. The data set is totally from one of a dyslexic person, so it works well on motorly disabled patients. Now let's move on to the course files in this SRC data. We have one file called the api.js, that was a JavaScript file that we basically had to create different checkpoints or endpoints to our API. Running this API, the backend and frontend gets run on different local hosts. Now let's first try to access our frontend. Here we click on the load EEG data, where the entire data set of ours gets uploaded in the backend. As you can see that we can also visualize the EEG signals uploaded from our dataset. Then we click on process EEG signals. In processing, two types of processing was done. That is, one was temporal and the other was spatial. On processing the dataset, actually happens behind the scenes is that we have applied a deep learning model having 4 different layers of CNN. Has a small kernel filter that works on small distance spatial severity, and the second layer of CNN had longer or larger filters that worked on longer dependencies. In between each layer, we have an RNN layer of LSTM, long short term memory, that is used to capture the temporal frequencies as well. After the pre-processing and the processing was done, the